And I'm going to show you some stuff that we've been doing on how to monitor APIs with Node and this open source framework called Frisby.js. It's running Jasmine. It's kind of like a unit testing kind of deal. So what this session is, trying to get feedback from you guys and see how you guys monitor APIs. So let's say we were to create some APIs, and how do you monitor it? I'll show you some of the ideas that we've been having. I just want to kind of curious in large what you guys been doing, like when you deploy APIs, like how do you even monitor that kind of stuff? So really, I think one of the problems is APIs are just proliferating and they're everywhere. Like even the applications that we've been creating in the last year or two, it's just really API driven. So for example, we would usually create like an API front end first, right? Like so all authentication, everything like user creation, editing, those will all be served out as an API. And even like internal stuff like authentication, like internally, we would be using API. We've been using a lot of stuff from like pre-made servers such as, I don't know if you ever heard of like OpenStack Keystone. So what OpenStack Keystone is, it's kind of like an orchestration software for, well, OpenStack is orchestration software for cloud. And they really modularized it. So Keystone is one of the services that their open source project provides, which is just authentication and user creation and things like that. So some of the projects that we've been doing was like, we would just spin up that server and it would provide you all the functionality via API already. So and then we would internally use that for user management. So it would create your users, you could update users, change passwords, get authentication tokens for a short period of time, long period of time, whatever you want, so that we didn't really have to rewrite all of that code for all the various projects that we made.
You say we, who's we?
Yeah, so this talk, I didn't really want to, I wanted to focus about the thing, so we're actually, so Lincoln and I, we're working on this project called AutoDevBot.
Okay. I just wanted some context.
Gotcha, no problem. But yeah, for this talk, I really wanted to take out the company from it. So I didn't really want to sit here and pitch you on like AutoDevBot, what we're doing. I didn't want to sell you anything. I just wanted to talk about like the idea. But yeah, so really what we're hosting is AutoDevBot. And this is really what, well, I don't want to go into that. I don't want to persuade you guys either way or another of what we're doing. So yeah, so what we've been seeing is that just, and when I say we also, so last 2 years, I've been starting this company called Algorithms.io. We subsequently sold it in November. It was a machine learning as a service platform in the cloud. And that was pretty much all served up via APIs. So this slide is from Mastery. So we kind of had an architecture like this, right? You have kind of user-facing APIs. So you might have like shipping and CRMs, and then you might have internal APIs that different teams are making, right? Like you would have accounts, you have inventory, you might have payroll. So like basically what this is kind of describing is different departments or teams creating APIs to serve internal needs. So one of the internal needs might be like inventory, like what kind of inventory do I have in my company? And that's all served out via API internally. So other departments in that company can utilize that however they want. The website front end might utilize that to put, if there's availability and things like that on the website for a certain product. Internal users might do, hit that API for accounting purposes and other purposes, right? So I'm not sure if you guys are seeing this, but I'm definitely seeing this where even in larger corporations, people are generally just creating API as a base layer and letting other people consume their APIs. So I'm not sure if you guys been seeing that, but I've definitely been seeing that a lot. And it makes it a lot easier to kind of grow from that because you're just delivering generic APIs out to your user base. And when they ask for something, so you tend not to create like GUI type interfaces, and you leave the GUI type interfaces to the end consumer team for them to create on however they want to consume these APIs. Right? So one of the problems that we've been finding, so we as in AutoDevBot and even last year when I was at Algorithms.io was that how do you monitor all these API once we push into production? So my role at Algorithms.io last year was developer and kind of DevOps operation guy. So it was a small team of like 5 people. And we had about, we were on Amazon, and it would go up and down to about like 50 servers or so. So in production mode. And then we had development and staging environments, which had about 5 servers for the staging and QA environment. And in the production, one of the problems was like, how do we monitor all this stuff? Because what we were creating was basically something that looked very similar to this. You rename the boxes to different things, and it looked very similar. Like one guy would create this, this box that would serve out some APIs. So what we were doing was machine learning. So these were like workers that crunched some data. And there were other boxes that were consuming streams of information in as a REST API. And the problem was once we pushed this out into production, it was like, how do you monitor this and how do you make sure it worked? Because we had a semi-continuous deployment system that we're deploying code into these various boxes, right? Once it gets through some certain gates, it would automatically deploy into these boxes. And how do we do this integration testing to make sure it works? So there are tools like that. So we use tools like Pingdom, Uptime Robot, and there are tools that are really, really similar to Pingdom, like Monesis and AlertSite, which are basically, it monitors websites. So you go into the web GUI, you punch in a URL, you say, I want to put, I want to get, I want to post. You give it some data. And it'll go out and reach out, like if you're familiar with like curl calls, right? It'll reach out to that URL that you specify, and it would grab that URL and make sure that whatever response that you thought you wanted, and it'll make sure that it was there, and if it wasn't, it would like email you or hit another URL for like a webhook to PagerDuty or something like that. But the problem with that was that it was GUI driven, and it was really hard to automate. They really didn't have an API that says, hey, I want to create this new test to monitor my new API that I've done. You really had to just go into the GUI and punch all this stuff in manually. So the problem was really creating new stuff and then updating other stuff, right? So if the API changed, I had to manually go in here and edit these from the web GUI, which kind of sucks. Because then you end up having, like 30, 40, 50 tests, and it's like, how do you even keep track of that?
No web services to make this. You had to go into a GUI.
You had to go into a GUI. So yeah, so that really sucked. Like that was the problem. Like I would be perfectly fine with using Pingdom with Uptime Robot if there was an API. But the other problem really was that this thing was kind of siloed into your operations thing too. Like your development QA would not be using this thing. I suppose if you did automate it, you can have your QA and development use it, but they tend not to use stuff like this, right? Like I'm not sure, how many people in here are developers? All right, everybody. Like I don't know if you guys use like Pingdom, like you guys would want to use Pingdom to monitor, a code base that you were like actively working on. Like I don't think that really makes too much sense. But so really like there was no good DevOps tool. So DevOps is really the merging of development and operations skill sets so that you can kind of highly automate environments, right? Like, so stuff like Amazon, there's APIs for Amazon. You could scale up and down. You could create environments. You could destroy environments. You could go as far as, you know, automatically deploying a new environment for every build you want, or, you know, to something in between that. And DevOps groups really don't want to run infrastructure. They've been tending to use services as much as they can. So kind of the rise of like tools like PagerDuty, New Relic, Scout, and a whole slew of other tools like AppDynamic for, you know, application performance metrics. So I don't know, how many of you guys use New Relic in here? You guys New Relic? You what?
I've just tried it out.
Okay, what do you think of it?
I mean it's okay. I don't really have a strong opinion on it.
Gotcha. But did it give you more information than you had before of your application?
We were writing our own unit tests before, so it was like kind of a pain.
Okay. Or how about even like database queries? Like one cool thing was like, okay, cool. Now like every single database call that I'm doing, if I tool it before and after, like I can see every single database call that I'm making and how long it's making. And if there was one out of whack thing that some guy makes some super duper query that like took like 30 seconds to run, then we, you know, that would actually automatically like pop up, right? We can be like, hey dude, like you got to optimize this query a little bit. We can't be having, you know, users sit there for like over 30 seconds waiting for stuff, which was cool. So really, like, where are the tools for kind of DevOps generation? So this was actually came from another slide deck that we've been doing. Let me skip over to this. So what we've actually been doing was using open source frameworks, testing frameworks for not only testing our code in development and QA, but we've been using it in production too. So we will run the same REST API tests in development while we're creating it, and then QA guys would be running the same stuff just to make sure it works. Developers would be creating these kind of REST API unit tests. The QA guys would be extending that for their side use cases, because, you know, QA guys like to break stuff, and they're like, well, what if I threw this information into the API, like these weird characters, or make these weird calls? You know, is your API still working? And then what we've been doing, even for the last company for Algorithms.io, was that we were using the same tests and running it against the production system to make sure that pretty much the system tests was working. So these open source, you know, we were running Frisby.js. And so here goes a Frisbee.js. Let me go over this a little bit. So it's based on Jasmine. And Jasmine is a unit testing framework for Node.js. And Frisbee.js kind of is on top of that, which puts another layer on top of Jasmine that kind of is dedicated and focused to REST API testing, like to build REST API tests. So it has structures like you can create and name it, and you want to do a get on this URL. Then you start expecting stuff, right? Like I think all this expect stuff is really unit testy, but for Frisbee, it has these methods that expect certain things, and it's looking for certain headers, right? So like this one, expecting a header status of 200 back from whatever you're calling it. And this one's expecting that header contains, you know, content type application JSON. Then you can start expecting stuff in the body, like JSON types, username, a field called username, and this field is a string, or this field that's a Boolean, age, which is a number, and it, you know, just tosses everything else. So we've been writing these tests in development and in QA for a long time now, maybe like a year and a half, almost 2. Then when we started deploying the code into production, we were like, well, how do we know this works? Because we found stuff where one API was upgraded and another API wasn't, and it just wasn't working. And somehow it gets through, staging and QA, or sometime in the beginning, like the deployment scripts were kind of not so great. So it would kind of deploy into some boxes and not deploy in other boxes. So you had kind of weird cluster state kind of going on. And we were just kind of struggling on how to monitor the production cluster. So creating a lot of the pingdom stuff was just really manual and just took a long time. And it just kind of became unmaintainable over time. So that's what we did in the beginning. But it just really became unmaintainable, in the long run. We had to go through every single one to make sure it was still cool, or we would add new ones, or we would delete new ones. And then we finally thought, it's like, hey, why don't we just run the REST API test that we were making in development and QA and run that against production. And what this gave us was really that it gave us a lot better test coverage than what Pingdom and other stuff that we were making solely for the production network. This was, we had, hundreds of these tests. So, like, the coverage was just way better, and the coverage was actually maintained, right? Like, it went through a life cycle where, if you were to touch this API, you would most likely edit these tests first, and then go and do whatever you were going to go do to your API. If you were changing the outputs or the inputs of this API, you'd probably go edit these tests first, and then go mess with your code to say, hey, OK, cool, now I'm going to return this new field. Or like, now we have this new field that we're picking off from the database and returning it. So these were actually maintained a whole lot better than trying to do this in like Pingdom or Uptime Robot. So really, oh, go ahead.
Did you guys sign to any of your own email notification or pager notification?
So we use PagerDuty.
Okay.
Yeah. So we didn't want to build any of that, right? And so we just used PagerDuty to plug it into this. So we just had it continuously running, and if this thing threw errors, it would just make a call out, with quick call, curl call out to PagerDuty's API, and then we'll use that for alerting. So that's good for like suppression. Like if it continuously failed, PagerDuty is good for like suppression. Like so I won't be getting 100 emails, every minute an email, I'll suppress it, and it'll escalate all that and do all that good stuff, right? So I mean, like I want to kind of open it up and see what you guys thought. Would you guys do this? Is this crazy, or is it?
The first thing that comes to mind is what about the effects on the production data? I mean, what's your consequence?
Yep. So that's a good question. So yeah, definitely we didn't run the full suite. There was another branch that we actually ran that had the good tests. Like so some of the destructive stuff we didn't run. So a lot of the stuff that was destructive against, for example, like deleting some data sets that our test depends on that were large. We didn't do that kind of stuff. And some of the internal APIs were, disabling users and things like that we didn't do. So there was definitely another branch that was the good tests, and we're like, okay, cool, we're happy to run this against production, and so we think this is not going to break production. So yeah, like.
What about reproducible state? I mean, typically you set up tests, you set a base state of the system. I'm thinking of old school, perhaps. Are these API stateful, where you've got to kind of kick them off in a starting state so that you confirm they transition in a certain fashion?
Yeah. So
you can't set a production in that fashion. production is.
Right. And it's not like unit tests either where like I'm pre-processing stuff. Like I'm not like dumping the database and putting it into a state that I want and then running my unit tests against it. So this is definitely, yeah, so we definitely had to think about running this against production where we never, we're pretty confident on how, like, let's say a database, right? Like how the user's table is set up. We never dump the user table, in production to run a test. So all the tests in the branch were tests that were good to go, that were saying, if a user were to run these, call this command against the API, it should return X, Y, and Z. So it's a little different than, straight unit testing we were doing, but not 100% different, right? Like we would take maybe like 30% out of this thing. I don't know if that answered your question.
Somewhat. Does it also give you latency on that?
It does. So yeah, so like this gives you all the metrics. So it puts out, regular kind of like JUnit tests XMLs and stuff like that, where you can use that and feed it into your integration system also. So we use this in Jenkins and have Jenkins run this in on the development builds and the QA builds, right? So yeah, it has all the latencies and things like that for every single call, which is good. But I'm not sure. Yeah, so we didn't really use it for that. Like, well, back then, New Relic wasn't really there. But then we had other metrics for like API latencies and things like that. But you certainly can use it for that if you wanted to. Definitely. So yeah, let me ask you guys, like, in your, how many people work for like a startup over here? Are they over 40 people? Under 40 people? Do you guys interact with like the operations team?
Yeah, we are the operations team.
Gotcha. And then so if you are,
we use Pingdom. I mean, that's.
And how's that working? How is that like that? Does that solve every single need that you have for monitoring APIs?
I mean, it definitely solves. Your APIs are down. It doesn't solve the case of, are all the APIs returning what they're supposed to be returning?
Yeah.
And, we've definitely had issues where like we updated API, everything looks good, and then a customer's like, hey, this field is not there anymore, and it's breaking this.
Yep.
So I think we need something like this to kind of handle that.
And then so this case right now, like how do you handle that case, or you just don't?
Yeah, we just try to be a lot more diligent about it. But yeah, I mean, it just hasn't been critical enough, I guess, to sort of level up into something that we sort of need to do something like this. But
Okay. And then are you guys, assuming that since you're coming to these meetups, you guys are writing like Node.js stuff?
That API is actually built in Java.
Okay, gotcha.
We also do Node.js for some other stuff, but not for the API portion of the company.
Okay. Yep. And curious, so like for like unit testing, what do you guys use? JUnit.
Yep.
And then for testing like the REST API, also JUnit for that also.
Yep. You can like mock up all the like web requests and all this other stuff. Some good Java libraries for that.
Yep.
So,
Yep. Gotcha.
and then on the Node side, doing like Mocha and Chai. It's the same thing like this.
Yep. Gotcha.
So, yeah, that works pretty well.
Okay. And would you, like, I think you guys could do the same thing, like, let's say, like, would you guys run a subset of those JUnit tests to test your API?
Yeah, ideally, that would be that. I mean, we also kind of run that before we push to production.
Mm-hmm.
So I don't know if that would necessarily caught the case for that guy's thing.
Gotcha. Yeah. But I'm thinking you probably have a unit test case now for that very thing. Okay, good. Yeah. Yeah, so I don't know if you guys would want to see more of, let's see here. So yeah, so we've been using Frisbee.js. So we've been writing a lot of Node stuff, and just in general, there's been using a lot of Frisbee.js stuff.
Can you get nested in the types?
You can. And then yeah.
Okay.
You definitely can. Like if you had a JSON, like a JSON, right? Like if you had,
so you had an array of things, you can say array element
Yep.
0 dot
Yep.
name dot.
Yep. Yep. And if it's array, you can actually say, like, you don't really care how many is in the array. You can go through every single array spot and check for structure integrity of what's in there also. Let's see, can I find the... So one weird thing about Node.js is really that, since it's async, that your tests might run a little funny. Your test just kind of runs funny, right? I mean, so all this stuff is async. It'll run all at the same time. So some of the problems that we've been running into, some of the stuff that we've been just running into was that usually you would have to authenticate before you did anything, right? So there's a setup, usually there's a set of public function for the API that you can just hit without any authentication, which is cool if you're, for async stuff, right? Like you just hit that all and you're cool. But there are some stuff that you need to authenticate first before you subsequently, use that authentication token in the subsequent call. So that's the only kind of, funny thing about these tests is that you would kind of have to nest it. I'm trying to find the... So really, they built in this after JSON function where this would be called, then subsequently anything that's in this block would be called. So that's like the pattern for most of our kind of unit tests where we would authenticate for this authenticated stuff. We would authenticate and then get the token back and then use that token to, like, say, update a user's info for that current user, like delete the tokens and stuff like that. So that was kind of a funny thing, well, I guess not funny, but I mean, that's just kind of the way that Node.js works since it's asynchronous in nature. But yeah, so that was really my whole talk here.